not really worried about that. You should be able to look at a parent function and answer questions like domain, range, increasing, decreasing. Can we do that if we're looking at a graph?
Yeah.
Domain is left to right, range bottom to top. When I talk about increasing, decreasing, you have to go left to right and you're listing your x values there. But the one thing that I wanted to touch on, again, is even, odd, and even, because it's been a little bit since we covered that. So I want you to decide if each of these is even, odd, or neither. And usually if I'm saying even or odd, we have a function, so it's function notation. What did we do to decide if something was even or odd? It had to do with the symmetry, right? If it was even, it was the same thing as symmetric over the y-axis, which meant a positive and negative x gave us the same answer out. If it was odd, it was symmetric to the origin. So when you put in a negative x, it gave you a negative y out. So what we did was plug in a negative. Okay, so I have negative 2 times. What is negative x times negative x?
Squared.
All right, so that gave me the same thing out. So both a positive x and a negative x give me the exact same y value. So what does that mean?
Even.
It is even. So if you plug in a negative and you get the original back out, it is even. If I look at this one, if you put in a negative x, if you take a negative to the third,
Negative
so this would be a negative 2x cubed, a negative to the fifth,
Negative x to the fifth.
okay, this is not what I started with.
But it's not the opposite.
It's the exact opposite. It's like multiplying my original by negative 1. So that means it is odd. What if I give you this one? So if we put in a negative x, a negative squared, is that positive or negative? Minus negative, so plus x. Is that what I started with?
No.
No.
Not the opposite.
It's not the opposite either, so this one is neither. What would be another way we could decide the even, odd, or neither? You could look at powers. If every power is even, it turned out to be even. If all of them are odd, it turns out to be odd. You could also graph it, couldn't you? And look at a graph and tell your symmetry from the graph. But there are some cases where I might give you something that's not a function, so we couldn't just graph it. So if I asked you to find the symmetry, if I said x equals the absolute value of y minus 2. In order to use our graphing calculator, it has to be y equals. So we would either have to make a t-chart and graph this by hand if we wanted to look at a graph, or we would have to follow the ways to check for symmetry. So remember, there were 3 types of symmetry. What are they?
X-axis, y-axis, and origin.
X-axis, y-axis, and origin. Remember, even and y-axis are the same thing, odd and origin are the same thing, but x-axis, that one's not a function, so it doesn't have an even odd term. So how do we check each of those? If I want to check the x-axis, what do you do?
Negative y.
Okay. The absolute value of a negative is the same as the absolute value of a positive. So this turns back into the original one, so that means it is symmetric to the x-axis. How do you check the y-axis?
Change the x.
Is there any way to turn this back into what I started with?
No.
No. So this one is not symmetric to the y. How do we check origin?
Change both.
Okay. So the negative in my absolute value would become positive. But again, there's no way to get rid of this negative out here. So this one is symmetric to the x-axis. Do you guys remember doing this stuff?
You can have 3 S's and 2, or 1 yes and 2 no's, but you can't have 2 yeses and
Yes.
okay. Or they can all be no.
It'll be all yeses or just one yes.
Or all no's.
Or all no's.
All right, last one. So if I want to check the x-axis, what do we do? Change the y. If you square a negative,
It becomes positive.
so that's what we started with. So this one is symmetric to the x-axis. How do you check the y-axis?
Change the x.
Okay, so if we square a negative, that's positive. And that is what we started with, so that one's a yes. How do we check origin?
Change both.
So both of those, the negatives become positive. And this is an example where it has all 3 types of symmetry.
So we can recognize that before we do anything, we can just write that we recognize it.
Just give me some kind of justification for it. Okay. So that's our review on symmetry, which will be on your quiz tomorrow. The second thing I wanted to work on today is transformations. Because I know when you're doing Math Excel, it's a little bit easier because you just click the parent function. You're not actually plotting as many exact points.
What?
So I wanted to kind of practice doing a little bit of that by hand.
Are you serious, Danielle, bro? Are you serious?
There's a table.
There is. Coming out of nowhere.
Oh yeah, I haven't seen that table before. That table's not from here.
What's new?
So are we gonna get the parent function?
That table's not from far.
You will have to be able to get them on your own. So that's kind of what we need to work on. All right. So if I am looking at this, when I ask for the parent function, you know I am looking for exact points, a minimum of 3. Okay, so if I take this first one, what is my parent function? Yep. So 0 squared is 0, 1 squared is 1, 2 squared is
4.
4, negative 1, 1, negative 2, 4. If you wanted, you could do 3, 9, and negative 3, 9, since you've got the grid in front of you. And how do I want you to plot that?
Dash one.
Okay. Now, let's figure out what the transformations will be. What does the 2 do?
Stretch.
Stretch it. Vertically.
Good. And what's the -5 do?
Right 5.
Okay, we've talked about, some of you like to write out your ordered pairs for the stretching and shrinking. It's not required. It is totally up to you, whatever works. If I wrote out my ordered pairs, what's getting changed in this ordered pair? The X or the Y? The Y. Outside is a Y and it does what it says. So we're really just multiplying these Y values times 2. So 0, 0, if I take my Y times 2, it's still there. And then I go right 5. So 1, 1. If I take my Y times 2, we're at 1, 2. And then I have to go right 5. If I took 2, 4, the stretch would make it 2, 8, and then right 5. And then we have our other points. So we would have -1, 2, right 5, -2, 8, and then take that right 5. Remember, if you have stretching and shrinking along with up and down needs to be the last thing you do. I missed my points. Pretend I didn't.
Perfect.
Yes, it's beautiful, isn't it? So we get a little bit skinnier graph shifted. All right. Is that one okay? All right, 1 and 2 are probably some of the hardest with the stretching and shrinking. That's what we've struggled with a little bit more. When I look at number 2, that 3 is on the inside. So what is that going to do?
Change the X.
Yeah, it's changing my X. So it's a horizontal. Inside does the opposite, so it will actually shrink. And what's this +4 going to do? Parent function, what does it look like? Yeah, absolute value looks like a V. Absolute value of 0 is 0. 1, 1, 2, 2, -1, 1, -2, 2. Okay. When I look at these, that 3, is it changing my X or my Y?
X.
The X. And it does the opposite of what it says. So it's saying X times 3, so I will take my X and divide by 3. So 0, 0 won't go anywhere. But then I have to move it up 4. Okay. This point would become what?
1, 3.
That 3 would make it a 1/3 one, and then we have to go up 4. This would become a 2/3 2, and then up 4. -1/3 1, and up 4. -2/3 2, and then up 4. So we're just getting this very skinny absolute value.
Ugly graph.
Are you judging my graph?
No, like the graph. Like, this is ugly. It's like a skinny graph. Just like nasty points.
He's being very rude today.
I noticed.
Don't mess with fractions.
Nasty fraction.
All right, is that one okay? All Alright, why don't you guys see if you can do 3 and 4? There's no stretching and shrinking on those two. You do have some reflecting. So take a second and see how far you can get with those two. Parent functions.
Because he pays you.
We can put them,
Sorry.
can make a t-chart if we need to. Cube root of 0 is 0. Cube root of 1 is 1. What's another nice number? Cube root of 8 is 2. And then you can do the negatives. So -1, -1, -8, -2. Okay, so what does a negative out in front do? Over. And what's the +3 do? Okay, so 0, 0 when I flip it doesn't go anywhere. And then left 3. 1, 1 when I flip it goes down here. Left 3. 8, 2 would go to 8, -2. Left 3. This one will go up. -8, -2, go to -8, +2, left. So we should get something like that. Could you tell me domain and range on any of those if I ask?
I'll remember.
How do we write it?
Negative, positive,
Okay, thank you. All right, number 4, what's my parent function?
Square root of x.
Square root. Square root of 0 is?
0.
Square root of 1? Square root of 4? If you wanted square root of 9?
3.
Is it okay if we skip the square root of 4 and just went straight to 8?
As long as... I mean 9?
Yeah.
Yeah, as long as you have minimum Greek ones. Fine. And then, a negative on the x. What will that do?
Flip it.
Put it on the y-axis.
Alright, if you're making your x's negative, we flip over the y. And the -5 will take it down because it's not under the square root.
My bad, bro.
Alright, so 0, 0 when I flip it stays there. Down 5. 1, 1 if I flip that over the y comes over here. Down 5. 4, 2 would go to -4, 2. And then down 5. 9, 3 would go to -9, 3. And then down 5. How are we doing so far? Okay. Let's practice another stretching and shrinking. All right, so number 5, what's my parent function?
Chair.
The chair, the cube. So 0 to the third is 0, 1 to the third is 1, 2 to the third is 8, -1, -1, -2, -8. All right, the 1/2 is out in front, so it affects y, and it does what it says, so it's a vertical shrink. The -4 will take our graph half.
Right.
Right. 4. All right, so 0, 0. If you need to, you can write out points. What are you changing on these, the x or the y? Okay, so if I take my y times a half, that doesn't go anywhere, and then write 4. 1, 1. If you take your y times a half, you get 1, 1/2, and then write 4. 2, 8. If you take your y times a half, you get 2, 4. Alright. -1, -1, we'll go to -1, -1 half. Right, 4. -2, -8 would go to -2, -4. And then right. So we just basically get a shorter version that's been shifted over. Number 6, what's my parent function? Parabola. 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. You guys all know where I get those points? Okay, a 1/3 on the inside, what does that do?
It's horizontal stretch.
And the +2? So inside changes x and does the opposite of what it says. So what am I actually going to do to my x's?
Times 3.
Times 3. So 0, 0 wouldn't go anywhere, but then we have to go up 2. Alright, so 1, 1, if I take my x times 3, would go to 3, 1. And then move it up 2. 2, 4 would go to 6, 4. And then up 2. And the same thing on the negative side. So we had -3, 1, shifted up 2. -6, 4, shifted up 2. And I want you guys to try the last 2 for me. Alright, so the first one, our parent function is the absolute value, so that's your V-shaped. What's the negative out in front do? What's the -1 do?
Right 1. Up 3.
And +3 is up 3. Okay, so if I flip 0, 0, it doesn't go anywhere. Right 1, up 3. If I flip 1, 1, it goes down to -1. Right 1, up 3. If you flip 2, 2, it goes to 2, -2. Right 1, up 3. And you can do the same thing on the other side. So it should look like that. Sound okay? Number 8, your parent function is the cube root. What's the +2 do? And the -4? Alright. So you should get something like this. Are we doing okay on these transformations? Okay, I want to, for now, go ahead and jump down to this part. Those 4 problems right there, we're going to do those at the beginning of class tomorrow, just as a little more review before our quiz. But this one we had some on our handout Friday that we practiced. I'm giving you a point and I'm asking you what the new point would be. So I'm starting at -2, 3. Okay, if I say f of x minus 2, what will that do to my graph?
Right, 2.
So if I move -2, 3, right 2, where does it go?
0, 0.
14, when I put a negative out in front, what does that do?
Changes it to 2.
Flex with the x-axis.
Flips it over the x. It's like making my y negative. So my new point would be?
Negative 3.
Little 22.
Alright, if I put a 5 outside, outside is y and it does what it says. So this says I'm going to take my y value and multiply it by 5. So it becomes -2, 15.
See what I'm saying? It's kind of nasty. I told you.
The 3 on the inside, what does that do?
X
Divide by 3.
times
It changes your x but does the opposite. So I'm going to divide my x by 3. So it becomes -2/3. 3. Alright, 17. Outside is y, does what it says. So that's telling me to multiply my y by 1/4. Okay, so x doesn't change. My y value is 3 times 1/4 would be 3/4, or 0.75. 18, what does a +6 on the end do?
Up 4 or up 6.
So where does it go?
What'd you get?
-2, 1.
Alright, number 19, a 3/4 on the inside. Inside is x, and does the opposite. So what I need to do is take my x value and multiply it by 4/3. -8/3, 3. Let's add number 20 here. Last one for today. If I said f of -x, what would I do? Flip it over the y. So that's really just changing the sign on my x, so it becomes
2, 3.
2, 3. So all we're doing is changing the sign on these. Okay, so tomorrow's quiz is going to cover transformations and symmetry. Please don't lose this handout. We'll do those last 4 at the beginning of class tomorrow. And then